Yo, yo, yo. What's happening, people? Am I coming through loud and clear? I hope so. Ooh, we're making use of the emotes already. Can you see me? Hello? Howdy. Good evening. Just sorting my bits and pieces out. I think we're good. Ooh. We got 2 subs pretty much straight away. Gomboss has come in and he's gone for tier 2. I wonder why he's gone for tier 2. Someone wants the get system emote that's just been approved. It's kind of hard to see because it's so small. But I'm hoping that in some context that will be way more visible. So thank you for that, Gomboss. And Mongo is back in the house with a tier 1 sub. Thank you very much. 3 months in a row. What a legend. Thank you for that. So good evening, everyone. We got Mugu, we got Zorcat, Gomboss is in, Atwolf, Archbishop, Mongo. You're all wonderful humans. It's lovely to have you back on stream again. T, the T emote. So I don't have the same cup as what's in that emote, but I do have my regular Yeti thermos. This time it is filled again with Gaiokuro because hacking without tea is very uncivilized. So cheers to all you drinking tea or eating fish and chips. Not black tonight, Mugu. No, we're going to stick with the green, I think. Fishing was amazing. Yeah, it was beautiful. For those people who didn't know that I was bragging about being out on the river with the boys and Amy, enjoying a bit of fishing. It was lovely. Lovely to get out there. Yes, we are actually up for a new background. You are correct, my friend. Oh, Barney's in again. Thank you, Barney. Tier 1, hey? 3-month streak for you as well. Thank you very much. Gonna shower and enjoy thinking. Oh, great. What an unpleasant surprise. Yeah, so yes, we are up for a new background. I was thinking about that just now, but because I was running a little bit late getting all of the bits and pieces lined up, I thought I'll leave that until the next stream. I actually know what I'm going to put on the next stream too. So, chocolate. I hope you guys have some chocky. Fish and chips, I guess, doesn't go with chocky. But this is a new chocky that Amy brought home for me. So it's Green and Black's Smooth Dark Chocolate Mint flavor. Now, it's only 70%, but I am a sucker for some mint, so I'm going to give it a crack. Have you guys tried this stuff before? Let's see how we go. I actually think one of the boys might have snuck me some of this earlier on. I trained them well, eh? Chin chin. Ooh. Very tasty. That's the kind of stuff that will get me in trouble. I should show you this as well. This is a little gift that I was presented with when I was over at the MSF Hackathon by my good friend Pierce Barry, who works for Rapid7 on the Metasploit project. Check it out. It's a little Rocket League badge with the DeLorean car in it. How cool is that? That's so cool. So I'm pretty stoked that I got that. So thank you, Pierce. You're a legend. Describe the flavors. Okay, so it does have a classic dark chocolate flavor. So it is still quite sweet given that it's 70%. But you can definitely taste the cacao. And the mint is, it's not a full natural mint flavor. It's got that partially synthetic, but it's still kind of crisp, still kind of clean. Big fan. Very nice. Happy with that. Hey, Sparkle Ops is back in the house. Welcome again. Good to see you. Thank you again for joining in on stream. Much appreciated. Now, where do we get to? Strayu. Hello, Strayu. I don't believe I've seen that name before. Are you a first timer? Or do I know you by another name? I like to try and keep track of everyone who's tagging along, particularly when they wave. So you are a new face. Well, thank you very much for joining in. It's lovely to have you. Everyone, make Strayu feel welcome. We're very much happy. We are very much happy to have new people come in. So feel free to sing out with your questions. There's a good number of people that have been on stream with me since this particular series started. And I'm sure that if I don't see your question while I'm ranting about my thing, there's a number of people who will be able to point you in the right direction. So sing out if you get stuck or if anything's confusing. Now, in case you can't see, well, you should be able to see just above my head. It's there. Part 20. Woo. Part 20. I can't believe we're up to part 20 already, and it still feels like we haven't done anything. Like, clearly we have. We've got a borderline fully working session. We've got comms. We've got TLV packet encryption. We've got TLV parsing. We're working through our standard API implementations. We're going to have to start working on some more core stuff soon, though. So that's a bit of a win. Nice use of the T emote. I love a good T. How good is T? T is so good. Geez, we live in a privileged world where T is so good and so readily available. I am, for one, very grateful. So yeah, cheers. Cheers to you. So tasty. Yeah, so we've still got a long way to go. We have achieved some success along the way, and I hope that you folks have learned and continue to learn. One thing that I want to mention is that after the last stream, which was a week ago, forgive me because I needed a day off to get some rest. A week ago, I got off stream and I thought, okay, so how well are things working? Like, are people getting the things that they're looking for out of the streams? Is it becoming too tedious? Are we getting lost in the weeds too much? All that sort of stuff. So I threw a poll out on Twitter and I mentioned it to the crew in the Discord channel, and I asked the question, do you want to continue seeing every single line of code that I write? Because, if you take the last stream, for example, there was this tangent that we had to go off to try and figure out what was going wrong on the MSF side with regards to our new Meterp side, because clearly we broke something in MSF that was causing native Meterp sessions to fail, and that was interesting. It was good to uncover. But then from there, we're sort of working our way through the motions of just trying to implement some of the arguably not so exciting features. So I wanted to know whether or not you folks were open to me continuing with every line of code, or whether you wanted me to, let's say, bash some code out behind the scenes and then on stream we can review the stuff that I'd done, or if there were any other sort of flavors that people wanted to entertain. And for the most part, like more than half, like considerably more than half, said yes, having everything on stream is proving to be very valuable, particularly for those people who are new to development, even more so for those who aren't familiar with C#. And that people are getting just as much out of my ramblings / thought process as I'm bashing things out than they are from me just implementing cleanly. So there were maybe about a third of the people voted for do whatever you like, and as long as you review it on stream, that's okay. There was some good feedback in the comments, but at the end of the day, I've got to try and keep the masses happy. And my original goal was to make this all completely transparent. So continuing along this path, I think, is the right thing to do. So at the end of the day, when this is all done, it's better to have too much information on stream than not enough. So that's effectively where we're at. But if you got comments about that or questions, or you think that that's a really bad idea and you're very convincing, then I'm certainly open to it. Mugu, last reminds me, software development experience week. Software development week. I'll wait for you to finish your question. So anyway, what we need to do is probably pick up where we left off, although I think this is going to be a little bit painful because where we stopped last time, we stopped at sort of 2/3 of the way through a arguably successful implementation of the get interfaces command that's in standard API, listing all the network interfaces. And looking at the MSF side of the code was particularly nasty. It kind of had a bunch of assumptions. I'm thinking we're going to have to find a way around those assumptions ourselves in the CLR version. So we might have a quick squiz at that. And, if we can nut it out fairly quickly, we'll do that. And if it's a little bit more painful, what we might do is put that one on ice and maybe move on to another command and start working our way through either some more standard API commands, or we can start looking at something like implementing channels. Now, I think the best way to approach implementing channels is looking to implement an instance of a channel first. So such as executing a process and being able to interact with it, or maybe opening up a TCP listener or something similar. excuse me, and then shuffling data back and forth, and then having the channel implementation kind of evolve as we go through the process of making one of those channel types function correctly. So last week reminds me how my software development experience, small changes will cause failure somewhere. Yes, absolutely right. Absolutely right. You can, and that was, you probably remember, it was just one thing. We had a mixture of things going on. So we had two calls. One is core load lib, one is core ext enum cmd, which basically means enumerate the extension commands. And so that lets you know whether you've got any commands wired in that are associated with a particular extension. Now, both of those calls should return a list of commands. So when you load a library, it will return a list of commands that are now associated with that library you've just loaded. And with the enumeration command, it should show that which is already loaded. Now, both of those are the same. The results are the same, but the load lib expected a bunch of TLV types that were methods, and the enum ext commands expected strings, and we had them both the same, and that's what was causing the problem. So I tweaked that in the MSF side, thinking that was busted, but it wasn't. It's just that they were out of whack. So I caused more problems for myself by doing that. Anyway, we'll get back into the networking code in just a sec. One quick shout out to KiwiCon again. See, where is it? Oh, there we go. Oh, it's on that side. There it is. These guys are great, and this jumper's very warm, which is why I'm wearing it. It's been a bit chilly lately. Enough of my face. Let's go to VMware. Now, hands up if you remembered where we got to last time. This is pretty awful having to dig through this stuff. What we might do is just quickly have a look at what these sessions look like again. So there's a 32-bit session we're going to kick off. And we'll open that one up and if config that puppy. So this is effectively what we're trying to replicate. Now we know we're not going to be able to replicate this because our interface index in this scenario is -1 when we do the CLR version. And like, that's not really that big a deal. We could hard code it so that if there is a 1 in place a -1 in place, we return a 1, but I'd rather not have sort of instance specific hacks doing things like that. So let's have a look at what the CLR one currently looks like. If config. So interface -1, we have the name. Now check this out. We've got, oh, hang on, sorry. Hardware Mac, yep, that's fine. Now the MTU, that looks like a -1 or something similar, right? Which basically implies that the MTU doesn't exist. Now, if we look at the way things work behind the scenes in the CLR version, we'll see that the MTU is actually blank, which is why we're not passing it through, which I think is probably a more valid thing to do at this point. We can see here we've got IPv4 net masks and IPv6 net mask on our loopback, but we don't have them here. I don't necessarily think that's a problem, but what we might do is debug that. Now, this is exciting because last time I ran this didn't actually make a great deal of sense, but we're very close to having it make sense. If we look at this, we can see that the IPv4 address and the IPv4 net mask are sort of together, but for some reason, the IPv6 is picking it up. So we need to understand why we are seeing the net masks come through incorrectly. Someone else has done a thing. Who is the thing? Rasta Mouse has just subscribed. Tier 1, 3rd month in a row. Thank you, Rasta. It's a pleasure to see you back, my friend. I hope all is well with you and your new mission. Shout out again to our friend Rasta, who does an amazing job of building some epic learnings over in the, what's it called? I've forgotten. It's called Rasta Labs, but it's hosted in... Remind me, Rasta. It's hosted at... Hack the Box. Hack the Box. Thank you. Hack the Box. Remembered. So yes, go check out Rasta Labs in Hack the Box. Hack the Box. I can't believe I struggle to remember that. Am I all glittery again? Looks like I'm glittery on camera. I like the glitters. It's kind of cool. That's what happens when I wear black. So what I'm interested in right now is looking at this particular interface and seeing, one, why this IPv6 net mask is coming through with what's obviously the IPv4 net mask. Now, if we look up here, we can see that the IPv6 has its own net mask, and we should probably be seeing that come through as well. So let's go and have a dig around and we'll see what we can find. So going back to Windows 10. Now, I'm going to hit a breakpoint here and just let it run for now, because we're going to run it on when we actually invoke it ourselves. All right, so if config. Now, we know that the first one's going to be the loopback, right? So let's have a look at this network interface just here. We should see that it is, I think it's the loopback. Oh, no, it's not. It's not the loopback. It's actually the one that we're interested in. Okay, so that's good. Now, if we have a look at our immediate window, you can see that it's Ethernet. It's a gigabit Ethernet, which is good. Now, if we get the physical address of this, that's the MAC address, so we know that that's all good. The IP properties of this interface are nothing particularly special. What we look for, that's right, what we want to look at is the IPv4 properties. So IP4 props. Okay, there's the index, which we can see just coming up through interface 7 there when we return the result. We can see that it is DHC enabled, that the MTU is 1500, and so that's when we're seeing the MTU come through here. Now we should be going through after this and adding the going through the unicast addresses. So what are we doing wrong here that's confusing? So we're adding a net mask when we know it's a internetwork address family. So this is the IPv6. Now this is interesting, isn't it? So we're actually parsing the IPv6 address first. Maybe this is the problem, because with IPv6, we're not actually adding the net mask, are we? Because we don't have one through our current address. Do we have a net mask associated with this? ADDR. Now we've got an IPv4 mask, which makes no sense because it's not an IPv4 address. So how do we get what is effectively the net mask for this particular address? This answers our question, doesn't it? Barney of the Rubble has just subbed at tier 2. Gee, thank you, Barney. That's very kind of you. I have a feeling I know what this is about. Someone wants to make use of the get system emote. Did I typo my ID? I don't think I did. I don't think I did. Oh, look at him. He's gifting subs again. You've gifted 20 subs, man. That's insane. You need to stop spending money on me. I'm not worth it. I'm very, very kind of you, but that's just ridic, my friend. Absolutely ridic. You're a very kind man. Very kind man. So what we need to do is get the IPv6 net mask. So let's see if we can do that. .NET C# get IPv6 net mask. Calculating all addresses with subnet. Nope. Map to IP4. How do you IP address and subnet mask of a local machine? I guess that's interesting. Let's see what they do here. Subnet mask. I'll look up the IP system's host name. Let's see what these people are doing. So they're actually going through network interfaces, getting IP properties. .gateway address. I don't think that's really going to give us much. That gives us the IPv4 mask, which is exactly. Hello, David. I'm just going to stop at David. David 3 Chorvath. David 3C Horvath? Not quite sure. Let's call you David. Welcome, David. Thank you for joining in on the stream. That's awesome. Yeah, okay, so Mongo, I'm really glad you said that because I was wondering if that was the case myself. Now, if that is the case, then why are we seeing a net mask appear, for example, here in the native Meterp? Does it? I mean, someone who knows much more about this needs to speak up because my area of understanding, or my depth of understanding of IPv6 related stuff is pretty weak. So the networking gurus out there should chime in right now because, like, clearly there's something up here. How to IPv6. All right, Barney. So if there is a IPv6 net mask, why can't we see it hanging off the address that we currently have access to? So one would assume that we would have access to it in the same way we would through an IPv4 mask. Now, you know, the .NET framework clearly covers for IPv6 address. You can see there's a %7, so I'm assuming there's the scope ID right there. Do we even output that? No, we don't. Bath 1%7. Maybe what we need to do here, when we actually return, what do we got here? So yeah, the scope ID is, maybe we've got this around the wrong way. Let's just have a quick look at how the scope ID is actually rendered. Because in native Meterpreter, we don't even see it, which is very interesting. So we might return it, but we don't actually render it. There is a prefix length. Right, okay, so are you saying that we should just be returning the prefix length and that's it? Because that's effectively the same as the net mask? Hello, Sad Lake. Thank you for joining in on the stream. Welcome. Okay, so, all right, well, what is that Aaron's sharing with us? Let's just, what do we got here? I'm going to do the copy paste thing. What is that you're suggesting, Aaron? I'm a little bit confused by what you've just pasted and how it's helping us. Example. Oh, okay, from Unix. Yeah, okay. So what are we doing? We are building a CLR implementation of Meterpreter so that we can run our Meterps under .NET without having to go native. No, the network section. Drinking tea and eating chocolate is also technically correct. Drinking tea. Aha, I see. You understood nothing. Okay, so someone can probably provide some linkage for me while I'm babbling, but Meterpreter, if you don't know what Meterpreter is a basically a remote access Trojan. It's like an agent that runs on a machine that you've compromised when you're doing penetration tests, and it's the thing that talks back to Metasploit when you've popped someone's desktop. And if you are lucky enough to get a shell on a box, that can come in various flavors. That flavor can be native. It can be a compiled executable that is a native executable. It can be PHP in a web app. It could be various things. In our case, we're looking to build a new version of this thing that will run directly on the CLR, so the .NET runtime that Microsoft have built. So we're building a whole new flavor of that agent that will run in that way. Voila. Don't set the prefix right, and it goes. Okay, so hopefully that answers your question a bit more, Sad Lake, but if it doesn't, then I recommend jumping in on the first of the series. There's a link to the start of the series, I'm pretty sure, in the Twitch channel. And you can start watching this series from scratch, and it will definitely explain all of the things that we're doing and how we even got to where we are right now. Right, so what we want then is the prefix length. So where are we going to dig that up from? Is it on the interface? Pretty sure it was on... It would be on the address, wouldn't it? It's not on IP4 props. Pardon me. ADDR.address. It's not on there. Through an exception of socket exception. Yeah, we don't care about that. I can't see anything in here. There's preferred lifetime. Here we go. Prefix origin. Oh, we came here last week, didn't we? We didn't know where we can find the prefix length. Yes, the Discord. Would someone be so kind as to paste the link to the Discord channel? I actually don't have a bot set up to respond to that. Sorry, sadly. But again, there's a link to the Discord channel on the Twitch page. My bad. Clearly, I'm terrible at streaming. I need to get good. So let's do this then, right? .NET C# get IPv6 prefix. Here we go. What do we got here? Don't tell me to go to WMI. Blech. We don't want that. No. Don't want. No, not doing that. We don't want that. Come on. There's got to be a way of doing it. Here we go. What's this? IPv6 interface properties. Where do we get that? Get the network interface. Get the global properties, and then across the adapter, if it's IPv6, then what can we do? Get IP. There's a get IPv6 properties. Really? Or is this... Let's just make sure that this is specific to the .NET version that we are using. Get IPv6 interface properties. Yeah, it looks like it is. The following code is get an IPv. Right, okay. This could well be what we're looking for, people. So we get IPv4 props off it every time. And if this is IPv6, we should be able to get... Thank you, Rasta, for sharing that link. Much appreciated. Yeah, let's see if we can actually get ADI.get. Was it the address that we get it off, or is it IP? IP.get IPv6. Here we go. IP6. This is gonna open the door for us. Get IPv6 properties. Okay, so we've added the IPv6 scope. Let's see what we can get off this now. I'm just gonna set a breakpoint on the SID. Build, and we're going to rerun that. So you can see what real system shows. You need a real IPv6 interface. Yeah, maybe we do. But let's just have a look at what this IP IP6 Pro, which I mistyped. What's it got? Index 7. That's not particularly helpful, is it? It's got an index and an MTU. Bleh. Okay, so IPv6 interface properties and IP interface adapter.get IP properties. IPv6 interface property. Where do we get it from? So there's there's only index and MTU. That's really frustrating. I was excited there. I thought we were going to get way more off of it. Far out. Oh, hang on. Description dot. Oh no, description is a string. Where can we get the prefix? How do I get IP? Here we go. Let's try this. Map IP to v4, convert IP to short and alternative, IP address family. I wonder if there is some way of actually sort of casting an object to a different implementation based on the fact that it is v6. What do we got here? Is there a correct way to get IPv4, IPv6 address? Really? I don't like the idea of this. Don't think that's what I'm looking for. I mean, the loopback adapter information is not that helpful anyway, right? So we are sure the native meterpreter is giving real values. To be honest, no. I'm not actually sure. But what I'm trying to do, right or wrong right now, I guess, is emulate that, what the native meterpreter is actually doing. Maybe that's the wrong thing to do. Like, maybe we should actually skip the whole loopback interface anyway, right? It's not exactly helpful. It's not giving us stuff that we necessarily don't already know. So maybe we should skip that. But we're not even looking at loopback right now, right? We are looking at this. So we should be able to get the prefix, I would assume. Unless I'm missing something. That chocolate's really Moorish, people. Like, really, really Moorish. Dangerously so. IP coming on my real IPv6 does not give anything that looks like a subnet mask, even though that's defined on my interface config on the adapter. Yeah, right. Gonna sneeze. Excuse me. Okay, so this was the one here, right? We've got an IPv6 address here with the scope ID of 7. Yeah, there's nothing here that talks about an IPv6 subnet mask, which is interesting. So where would the native one be getting it from? I mean, we were looking at the implementation of that last time, right? From here. We pass in the scope and the IP. That's all we pass in. Here we pass in the IP. This is getting the prefix from the first unicast address. So the pointer to the address is a unicast address. So it's getting the prefix directly from the P prefix, which is, excuse me. Did we dig that up somewhere else? I think we did. First prefix. Oh, this is the one that enumerates the entries out of, what's it called? Oh no, that's off the adapter. So apparently the prefix is off the NIC. Interesting. Is that what we were seeing here? IP, NIC, description, ID, name, network type, status, speed, supports multicast. It's not really anything else on there that you would assume is going to give us what we're looking for. Address, status, properties. Yeah, I really don't know how to get what they're referring to as the prefix out of this, you know? Hey, Parody's in the house. Welcome, sir. And the man has pulled out a sub. Thank you very much. 2 months in a row at tier 1. Much appreciated, my friend. Thank you for your support. I'll do it. NetSH. Interface IPv6. Show. Show what? Prefix policies. IP stats interfaces shows interface parameters. Yeah, there's like nothing here that really says what that should be. Show ADDR. Let's do that then. Okay, so there you go. It basically shows exactly what I would expect. And there it is there. So, I don't know. I don't really know what to say about that. Maybe what we should be doing here is like adding, in the case of IPv6, what we could do is just be really, really cheeky and add an array of bytes of 0 length. Now, I don't even know if that's a thing. But the reason why I'm suggesting that we do that is because we need to pass in the net mask with the IPv4 address only. Does that make sense? Okay, wrote up a quick gist of your future stream bot to quickly explain what's happening. Ah, Gombos, you're a legend. You are a legend, my friend. Thank you. I will implement that and sing your praises. For our on next stream, so thank you for that. I need to actually get a bot in here to respond to a bunch of commands, so I will wire that in. Thank you very much for your efforts, my friend. That's awesome. All right, back to here. Let's just give this a quick spin again. Fire this off, and we'll go back to here. Oops. Ooh. Invalid address format. Okay, so specifying what is effectively a blank isn't going to help us, is it? So maybe what we need to do then, what would be really great is if we could actually enumerate over these, because by the looks of it behind the scenes, there's an assumption that we're going to get IPv4 addresses first. So what would be nice is if we could actually add IPv4 followed by IPv6. Here we go. Order by now is internetwork 2. Yeah, I'm gonna order by the address is what is it? Address.address family. And I'm just gonna order that by an unsigned integer. So this is a bit of a filthy hack, but I'm just going to give it a go, see if it works, and we can get rid of that. Okay. Is there a way to call that in C#? So the PowerShell command get spits out. Oh, does it? Get net IP address. Okay, let's see. Loop back. Prefix length is 64. Interesting. So there's got to be a way of doing that then. Maybe we'll go and look at the source of get net IP configuration and see what it says. Should we do that? Let's have a look at that in just a second. If config. Aha, there you go. I cheated. See how it does assume that IPv4 is coming first. All right, so that's a small win because that's fixing up a couple of small issues for us. And hopefully with the information that Atwolf has just given us, sorry, Barney has just given us, my bad, we should be able to hopefully get to the source of the problem. I love having you guys on stream. Everyone's keen. It was Atwolf, my bad. everyone's keen to get in and fix the problems with me. It makes it so much easier in many ways. So I'm really grateful for that. You guys are what make this more successful than it could possibly be without you. And don't get me wrong. I'm very, very grateful. Yeah, okay, you both found the same thing. All right, well let's go and find out what this is doing. I'm keen to get to the source of this thing. So we'll get net IP address. There's got to be it's got to be source of it somewhere, right? Should be able to get to the source. It'll be somewhere. Inputs, outputs, this is interesting. The Microsoft Management Infrastructure CIM instance object is a wrapper that displays WMI objects. Bah. Far out. I'm eating more chocolate. You guys should eat more chocolate too. That makes me upset. I mean, one would assume that if you have a reference, cheers, Gombos. If you have a reference to a goddamn interface that has an IPv6 address on it, you should be able to get the prefix length off it. Why is that not a thing? Let's go back to here and see. Just do one more check to see if we can actually pull this out, because I'm not gonna lie, I'm getting the shits. Right. It's not on the network interface because that doesn't make sense. We'll look at the address, which is currently IPv4. Oh, the first one was IPv4. We know it's an IPv6 address given that we are setting a breakpoint here, and that's where we've landed. Properties on this thing are literally just index and MTU. That's really not helping us at all. What else we got here? Address family. Is it link local? Is it multicast? Is it site local? Yeah, whoop-de-doo. Nothing particularly interesting there. Is there anything non-public? There is an LP adapter unicast address. There's a lease time. There's inner info. What's that? Oh, that's just looks like an internal reference to a very similar thing. Adapter address, non-public members. Oh, would you look at, there it is. It's in the guts of it, right down in there. Okay, so that's hanging off address. All right, let's just see what's going on here. ADDR dot. Let's see what other options we've got. We've got a lot of properties here. What does prefix origin return? That's just an enumeration. Gives the value that identifies the source of a unicast IP protocol. So an origin is transient, is DNS eligible, blah, blah, blah. Okay, so if it is hanging off the address, yeah, look, I'm pretty sure that we would be able to dig it out through other means, but what I'm really hoping to be able to do is pull it out through the object that we've already got reference to. And now that we've seen it hanging off this, under non-public members, adapter address non-public members, it's right there. So how do we get to this thing here, this network information adapter address? How do we get to the adapter address? Because by the looks of it, I mean, it's got a bunch of stuff in here that is kind of important, and it's like it's mapped to a higher level. So we've got this system IP address information, which doesn't contain what we want, but this non-public member we do. Now, I don't really want to have to dive into this through reflection, but that is effectively what we're looking for, right? Yeah, I don't know, I'm a little... Barney, we've already got a reference to that IP address, mate. What I'm trying to find is a way of getting to the guts of this object that we're looking at. Is it just me or is everything smaller? No, I think it always is. This is definitely a thing. But each one of these, I don't know how to change the bloody font size of these windows. I think, hang on, maybe if we go project, no, not project, tools, options, fonts and colors. Once we go here, I've got to choose like the right window. Immediate window, here we go. Let's go. Hey, there we go. How's that? Is that a bit better? I should probably do the watch window as well, right? But that's the thing, I gotta do it for every goddamn window. Tools, options, immediate window. I want to be able to use, is there an all windows? All text, tool windows. Size. And it looks like it's done nothing. Tools, options. Watch windows. Your changes to the following categories are saved. Some changes may not appear until you restart the app. Really? Really? Restart all the things for the sake of a goddamn font. Really? That's just poor. Oh well, if it works. There you go. Boom. Check that out. Nice and chunky. Alright, we shouldn't have to change anymore. That is much more visible now, so. Change the font, please restart your system. It's pretty bad, isn't it? Alright, so here we should be able to see how we've got ADDR, which has a set of non-public members, so things that aren't exposed. And you can see that there is an adapter address underneath. So this is no doubt an implementation detail that we're apparently being abstracted from, right? That is of type system.net.networkinfo.networkinformation.lp adapter unicast address. Now we can be cheeky, and we can absolutely load this shit right via reflection, but I don't want to do that. I really don't want to do that, because as soon as you start reaching into things like this, so we've got to get the adapter address out, and then we've got to get the length off of the adapter address. So this sort of like a double-decker freaking thing. Address and address length. But that's the value we want. We need this one. And it's making me sad. It's making me sad that, look, prefix origin is exposed. It's there. Why is this not exposed? System unicast address information. Can we cast this to something else? System.net.network information. System unicast IP address information. Maybe there's another type. Ooh. Sorcat, have you found something? Is that a sign that you have the solution? Don't disappoint me. Don't leave me hanging, bro. Where's the answer? What is the answer? Is there an answer? Network information dot system unicast IP address information. So we've got network information dot system unicast IP address information. System unicast IP. Is that what it was? System unicast IP address information. Yep. Search for that. Oh, get out of here. Check this out. We can get to the source of it now. Internal, so it's an internal class. And that's why it's not exposed. It's kind of abstracted. So we know that this is exposed as a unicast IP. Maybe, can we cast it to this? But it's internal though. And there it is. It's prefix length. That's what we want. Prefix length, adapter address dot prefix length. Inner address, prefix length. Hang on a second. It's right there. Look, it's exposed. It's exposed. We can see it. It's exposed. Why is it not there? Hey, that's really infuriating. I can see it in the source that it's exposed. Look at the last two lines in the constructor. Okay. IPv6 returns 0 for consistency with XP. Really? Prefix length to subnet mask. Isn't that interesting? Wow. That is an interesting find there, Mongo. What a mess. Surgically accurate emote usage there, Jan 808. Chocolate. I'm going through a lot of chocolate tonight. Wow. Okay, so actually, hang on. Unicast IP address information. Properties. Ah, Here we go. Let's do this. var unicast ADR equals is it hit? Oh, I was going to get so excited then. Because, like, if you have a look at... it's because that's 4.8. What does it say when we're on 3.5? Look at that, you bunch of jerks. Look. We got 3.5, prefix origin. If we go back to 4.8, prefix length appears. Okay, so they literally expose it. They expose it. Oh, that's so annoying. Looks like it might have to be a reflection. Yeah, well, it is a little bit upsetting, isn't it? I mean, yeah, it makes me sad. All right, let me just quickly rebuild this. We may actually just have to put a reflection helper in to say, I want to get a hidden method off of this thing, of this type. So we've got address, which we know behind the scenes has an adapter address hanging off it. Okay? And off that thing is the prefix length. Dot length. And we can wire this in as part of... In fact, you know what? We can make this an extension method. An extension property on the unicast address. And we can make that specific to the .NET 3 implementation. So let's add a new item, a new class. And we're going to call this, what is it? Unicast IP address information extensions. Unicast IP address information extensions. Public static. Okay, let's get rid of all this crap. Public static. Now we're going to, prefix length is an int, right? Prefix. Now we might have to call it like get prefix length, just so that we can highlight that it's a method. This, oops. Unique area, that's going to be from network information. I'll just go ADDR. Now, this is going to give us just a nice way of exposing what it is that we're looking for. Now, according to, I should have documented this already, right? Let's just do this again because I'm an idiot. 0. Build. Yeah, it is a bit bizarre, but it just goes to show that over time things do/don't improve. Okay, so under ADDR, under the address, we have an adapter address. Now we don't actually know what type that is, so we're just going to refer to it as an object. Okay, so let's go in here. We want to go var and I'm going to create something called an object extension, which will hang off all objects of all things. So this is going to be adapter address equals ADDR dot get, I'm going to call it get property of type, I'm just going to go object. Actually, you know what I'm going to call it? I'm going to call it get member because it's a non-public member. So we're going to go get member. And that's how it's going to look. So here we're going to have public stat. I'm going to move this to another class, and class object extensions. And yes, it's going to be reflection horribleness. I'm sorry. Move type. Where did it go? I don't want to have to restart. Okay, so then what I need to do is give it a name. I need to give it the name adapter address. And then off the adapter address, we want to get the prefix length. So we should be able to go return adapter address dot get member of type int, and that's prefix length. Okay, so that's basically what we're trying to do, right? So adapter address should have, it's only called length. So length. Okay, righto. Now we should be able to stop. And from here, we're going to open up object extensions. Gotta love this stuff, eh? Public static T. Get member of type T from this object obj. So this is going to make use of reflection. Hooray. So what we want to be able to do is go type of T. No, not type of T. Maybe what we should do is let's just do this. Return. That's not going to work, is it? Can't return null. Yeah, we should go with default T. Okay, so get member will take string the name of the member. Is that going to work? It is going to work. Okay, good. That's what I was hoping for. Okay. Now I need to know what type the object is, right? So we go obj.getType .get member members. There's probably a get member as well. Here we go, built-in get member, where we go searches for public members with the specified name. So we want this. Okay, that gives us the member, but that is a member of, like, it's like a member info. So you see how get member returns member info. I should actually, according to this, return an array. Searches for the public members with specific names. Now, let's just see. I probably should give it some binding flags as well. Because we want to say, we know for sure that it is, let's have a look. Specifies the value of the specified field should be returned. Okay, hang on. We know that it's non-public. Specifies non-public members are to be included in the search. That's what I'm looking for there, right? So we want non-public, and then we want to go member, assuming that it's there. Member 0. We need to go, we need to somehow get, we need to get the value out. So maybe, is that something that we use get type to do? We need to go get method, get member, get field? Just a minute. Such a horrible way to handle this simply, isn't it? It's so depressing. But if we put this wiring in place, then next time we see it, we should be in a good spot. I'm going to have to Google this. .NET reflection get value of private member. Hack all the things. So we need field. So is member then the most appropriate name? We should probably call it get field. So here we need to go get field. My type, non-public and instance. Okay, so we can do that. Binding flags instance. Okay, so that'll give us the field. And then how do we get, once we've got the field, we should be able to go field info.get custom attributes. That's not what I want. Get value, there you go. So then we want to go return field.get value off of the object that we were given, and we want to cast that to a type of T. Alright, so this makes a bit more sense. Okay, so then prefix length equals addr.get prefix length. How horrible. Hey Eric, my favorite part of the stream is watching the amount of tabs. Shut up. Yes indeed. Alright, so let's see if this works. So we get field, and the field is definitely a valid value. Let's see what's going on here. And then we're going to try and get a field of length. Ooh, specified cast is not valid, really. So what is obj? Field is a uint32. Okay, so I've just got the wrong type here. We need uint. I knew that. Boom! We have butchered things via reflection. Isn't that just awful? Now, the good thing about this is that when we do our .NET 4 version of this, we'll be able to if-def this out and literally just return addr.prefix length for the version 4 version of this code. So this is, we'll only have to include this code in the .NET 3.5 version, but it's just a shame we have to abstract it in this way. Does that make sense? Okay, so with that in mind, let's go back to the implementation in native, because again, we just want to see what they're doing with the prefix length. Prefix length here it's just an int. So we just add, we add it as a raw. Oh, how interesting. Uint value is already byte swapped. We add it as a raw instead of swizzling the bytes twice. Hang on a minute, but that's cheating. Cheaty little bastards. We don't need to do that. We can actually do the uint thing, which is exactly what we're going to do. So let's just make sure that that is legit. Netconfig. So what we can do is go tlv.add tlv-type.prefix standard API IP prefix. It is a uint. Excellent. BDFR, we can stick it in like so. Okay. Let's see if it works. All right, where is it? Oh, look at that. The net mask is a bit strange for IPv4, but we're getting closer. That's hilarious. Is that because we're adding it for every? I don't know, we're only adding the prefix length here. Why is this behaving strangely all of a sudden? Wolf, this is a great question. Sorry, I have glossed over this a little bit. So the beautiful thing about .NET is that there's a really epic metadata system behind the scenes in the assemblies, right? So your class is made up of public, protected, and private members, fields, properties, functions, etc. And all of that metadata is stored inside the assembly itself. So if you have a field, for example, let me just dig one up. I'm sure I've got one here somewhere. I don't even remember having file system feature. Command handler. Nope, that's not one. Let's go back to the base of metserve. There'll be one in here. Okay, so see here we've got this class called server and there's a private member called current transport. So even though that member is private, which means that when you're typing your code into your IDE, you can't go server.currentTransport because from the outside of the class, you can't reference this because it's private. But .NET's metadata knows about this. So through reflection, you can say, actually, I've got an instance of a server and I want to get a reference to this current transport. I can use reflection to say, I want access to that private field. Even though it's private, I want it. And so reflection gives you the means to access private members, even though they're marked as private. So there's effectively nothing sacred. So what we've done is we've abused that exact property in this way so that when we're querying this prefix length here, we're saying, right, on this address object, I want to get a private field. Maybe we should call it get private field. That would make more sense, wouldn't it? Let's call it get, oops. Let's call this private field. That makes way more sense. Yeah. So that gives us a reference to the private field. And we're saying we want to return this, get the field of ADDR. Behind the scenes, it's called adapter address. And by doing that, that will give us a reference to something of type object. Now, the type of the object, the type of adapter address is actually something else. But we don't know what that is. And right now, I don't care what that is. All I care is that I get a reference to it because that object I know has a value on it, another field that's hidden called length. So I'm reaching into address to pull out the adapter address object, and then I'm reaching into the adapter address object to get the length value out. Does that make sense? Hey, Smash is in. I didn't see you sneak in, Smash. Could reflection then mess up stuff if you're not careful? Without a doubt. So do not do this if you don't have to, which is why, so we can say if, what do we call it? Is it net, I can't remember, we call it net 3.5 or something. Is that what we were going to call it? I can't remember what else we've done in net 3.5, if debug, I can't remember. There's conditional compile. We have documented this earlier on. So my bad. Here we go, net 3.5. So the build system is also aware of predefined preprocessor symbols representing different target frameworks. Okay, so net 3.5 should actually work, right? See this, if blah blah blah, if net 4.0. So that's effectively what we want to emulate here. So what we're saying is, if this is .NET 3.5, which it should be, because if we look at the properties here, we are using target.NET Framework 3.5. We'll figure out what's going on. Then we will do our bastardized version. Otherwise, we're going to assume it's .NET 4. Okay, so if it's .NET 4, we're literally going to go return addr.prefix length. And the reason we're going to do that is because the prefix length we know is an exposed property on that address in that version of the framework. We might actually have to cast that to a uint, but that's no big deal. So only when we're using .NET 4 are we going to be using this prefix length property, because we know that it hangs off the object. And then with 3.5, we're just going to have to do this bastardized reflection. We are in, I guess, a fortunate position here because we kind of know that 3.5 isn't going to change. So the aim really is to completely avoid referencing inner member variables, because they could change name, they could change type. You really want to just use the interface, which should remain static. So yeah, pretty gross. Angry little hamsters back in the house too. With reflection to access private members, is it read only? You can write. Yes, you can definitely write as well. Gotta love how convoluted this is. It's terrible, isn't it? Oh, thanks, Smash. Yep, thank you for answering that. So yeah, that's basically what we're looking to do. So, I mean, technically, when you mark something as private, you're saying, I am responsible for how this kind of thing works, and you should just adhere to my interface, which is what public is all about, right? Because that's the thing that shouldn't change. But yeah, we're effectively saying, well, the .NET framework isn't giving us what we want. We want the prefix length out, and we're not getting it, so screw you guys. We're doing it ourselves. So that's the plan. All right, so let's just see where we got to with this, because if config. Okay, we're seeing some weird shit now. So IPv4 netmask is coming through very strange. We should be seeing like something else other than that. So that's working. Why are we not seeing the prefix length come through here? Is it because yeah, the prefix length is coming out correctly, right? Let's run that again. Right, so we are adding a value of 64 as the prefix. So that should be doing exactly what we expect. All right, so the packet has the things in it. This, I think, is the case where whatever's parsing it on the other side is making pretty horrific assumptions about how it's working. So what do we got here as well? We've got another prefix length of 64. And probably another one of 64. Yeah, so they're all 64. They should all be coming through the same, according to this. And based on what we saw before in our native meterp. Ooh, Jesus, look at that. See, those two are coming through 64, but the loopback is not. I wonder if that's because there's something wrong with the way this is being generated / parsed. Plus, there's no net mask coming through for. Yes, there is, and it's not what we're expecting to see, right? This is so weird. It's correct for loopback. It's a /120. Okay, cool. Yeah, that makes sense. What you are seeing is horror 64 prefix and horrid notation. Private will stop you from accessing the compiler, but you can do it. Yeah, that's very true. The only problem, Smash, is that with C++ you don't have the metadata. So in order to do it, you literally cast a pointer to a C++ object to like an array of bytes, and you offset into that array as if it's a structure, and you overwrite the field directly, yeah? So you don't even have the glory of metadata for that you would have with .NET. It is definitely more gross. I wholeheartedly agree with you. Man, we haven't achieved much, have we? But geez, we've hacked some shit up tonight, let me tell you. I'm still really confused as to why we're not seeing a net mask. So hang on, let's go back to this for a minute. And I'm going to rerun this command again. Because what I want to see is, okay, so our first address has a 25. That's the one we would expect to see first. 192, blah, blah, blah. Next one is, that's the IPv6. Oh, yeah, of course. That's the IPv6 address. So this is a different network interface. Okay, so this network interface is the Bluetooth one, which should have a net mask of what? Does it have one? Oh, this is the one that doesn't have one. Right, so then when we go in here and we check the net mask, it comes back and says, we don't have one. Okay, so according to this, look at this. This doesn't have one either. So when the native one works, oh, is that the native one? No, that's not the native one. Here's the native one. Okay, so the Bluetooth one has, it does get the net mask off it. Why is that? Where is it getting that from? We're not even seeing that on our object here, are we? Does anyone else recognize this tune? Eric, you should. LP socket address. Address length 16. Okay, so this is pulling the address length of 16 off. So maybe this address length is something we can abuse. Rocket League, yeah, Rocket League soundtrack. It's pretty good, isn't it? I'm feeling a little dirty here because it's like this address length somehow is being used to populate what we were seeing over here. Where are we getting the net mask from in this way? Bluetooth addresses are handled differently as they are. Yeah, exactly. But even though it's got an auto address, it should still have a net mask. So why doesn't it? What does the native implementation do? I don't think it does anything particularly tricky, other than always adding a prefix length, regardless of whether it's IPv6 or IPv4. So it always adds a prefix length. Maybe we need to do that. Let's do that, see what happens. It is doing it, so maybe we just need to be consistent. It's actually doing it before it adds either the IP. Yeah, it's doing it first. See what happens, shall we? Is that if condition on line 45 not working? This one here, it's definitely working because it's checking for IPv4, so it is coming in here. That's exactly what we would expect to see. Let's see how much stuff we break by doing this. Oops. If config. Ooh. I'm confused. What is going on here? That is just the loopbacks. Yes, the loopback's definitely wrong. I think we should only add the prefix to IPv4 if the net mask is missing. So I think we should either do get prefix length, like we'll add that in here regardless. And if it's not null, we'll do that. Otherwise, we will also add it here. Assuming it has it. Does that make sense? Maybe it doesn't. Still doesn't matter, make any sense because the loopback is still wrong. That's better, but we don't have... That's really odd. I would have expected to see this in here. But I'm guessing this has got something to do with the order in which things are being added now. So according to the native implementation, we always add... What are we adding for each interface? We start with adding the prefix if it's there, then IP, then scope. Prefix if it's there, then IP, and then scope. So maybe we do need to do what we did before. Alright, prefix, and we always add the IP. But the net mask, where is that added? Ah, that's not something that we do in this code. There's two versions of it, isn't there? Maybe that's part of our problem too, is that we're mixing the two. Net mask. Index IP net mask. What happens in here is we only do one or the other. This is one of the things that's a little bit confusing. Oh no. According to the pivot active prefix does this private XP1. Check for this by the length. Okay, so we definitely are doing this. So we shouldn't technically be adding net mask, right? According to this, we are always adding prefix. So maybe we shouldn't be doing this case at all. We should always just be adding the prefix. And that's why things are getting confused. That would actually make a little bit more sense, hey? Let's see what happens here. I am at a loss, I'm not gonna lie. But I also think part of the problem here is the way that the TLVs are being parsed on the MSF side. So I'm actually inclined in many ways to go and fix that as part of this. Yeah. This is fine. I don't really remember from the last stream, but there is literally no way of grouping IPv4 versus IPv6. Yeah, I don't know, man. So here's what we're gonna do. We're gonna we are on a separate stream. We're gonna fix this. We're gonna make it so that IPv4 and IPv6 address related stuff is separate and handled separately. And we'll probably have to make it so that that happens across all of the interpreters. Ooh. I knew this was going to bite me in the ass. I think we've learned something though. I think we've learned something. So what I'd like to do now, actually, we've got about half an hour. I think it is a bit of a big fix. Rasta, you definitely felt me right there, my friend. Okay, so here's what we're going to do just to mix things up a little bit, because I think we can do what I'm about to suggest in a short period of time and have it done by the end of this stream. And that is, let's get started on the .NET 4 version of what we've already built. Okay, and we'll get that cross compilation happening. And then later on, and as part of a different stream, we can fix this nonsense up. But right now, this is particularly upsetting. Yeah, sad, very sad. So here's what I'd like to do, and I'm gonna work through this fairly quickly. We're gonna create a couple of new projects. We're gonna start with a new project that targets .NET Framework 4. Okay, it is going to be a class library. Now, what did we call it on disk? Interpreter.net. We've got metserve net35, so this would be metserve.net 40. Okay, I'm going to do that, and we're going to delete all the things, but we're going to add existing items. We're going to go over to 3.5. I'm going to choose these things and make sure that we add them as links. Now this is where things might actually get a little bit trickier, because inside each one of these we've got, oh no, we've got metcore. We don't actually have the version number baked in. So that's good. Now if we have a look in the properties of this, we can see that assembly name is that, but our default namespace is this. So we need to set this so that it's the same, because we don't want the version numbers to get in the way. So we need to add a couple of folders, extensions. I don't want to manage NuGet, sorry. Add proto, add trans. Now we want to add existing item again here. We want to go, now we're adding extensions, so let's do all of these and add them as link. Same with proto. Where are we? Add existing item under proto, add as link. And then we do the same for trans, add existing item, add as link. Okay, so there's a couple of things that we're going to have to do here as well. You'll notice that in metserve here, as part of our debug, our build events, we've got that We've also, when we build stuff, see where we're targeting. Okay, so we need to make sure that we adjust our builds for MetServe 4. So we go properties, we go build, we want to go up one. And in release, we need to do that as well. Build, up one. And then we go back to debug and we go build events. We need to do this. Save. Moment of truth. Let's see what happened. So we should be able to go to Scratch, which is here. There's MetServe 4. Winner, winner, chicken dinner. So that actually built version 4 of our assembly, which is awesome. Are you going to make new versions of 4 stuff when you can do it cleaner even though it's working? Not sure I understand what you mean by that. I assume you mean if we can do certain things in .NET 4 that we can't do in 3, are we going to do it the .NET 4 way? The answer to that is most definitely yes, which is what our conditional compilation is going to be about. So if we look at, for example, extensions, I don't think this is going to work immediately. Hang on, where are we? Object extension, that's going to remain there. We've got our unicast IP address. So I'm going to figure out why this conditional compilation thing isn't working. I'm going to make that work. So I'm pretty sure, like, where are we? Build conditional compilation symbols. So this, for example, is net 40, which means, there you go. So prefix length, it does not contain a definition for prefix length. So why not? ADDR. Oh, maybe it needs to be. Oops. Z. This is basically what I'm looking to do, by the way, is do the conditional compile. We can leave. So we've got prefix origin. Correct me if I'm wrong, but we did see this. Maybe. Oh, actually, no. One thing that I checked when I was looking at this was not. Where we go? Prefix. Okay, so prefix length is in 4.8. It's not in 4.0. There you go. So I don't get to use it here. But that's effectively what I am going to do to make sure that we know. Wizard Engineer, would you rather stay with VS17 or go to VS19? At this point, I'm going to stick with VS17, and let me tell you why. Because the intent with Meterpreter native is to upgrade to VS 2017, not 19 for the native builds. And so I want to target the same version of Visual Studio for the CLR build so that there's no sort of issues with the build platform when all of the Meterpreters are built together. So for now, we're just going to stick with VS17, 2017. Okay, I hope that answers your question sufficiently. Righto, so with that done, we need to then go ahead and do the same for standard API. So let's go and do that. Add new project. Now, make sure I get this correct. Standard API net35. So this would be standard API.net. Or 0. It's going to be that, and it's .NET 4. Okay, so we can get rid of this. Now you see with standard API has a reference to MetServe net35. So here we need to add a reference to the project of MetServe 4.0. Okay. Now we need to duplicate basically what we're seeing here. So let's go add existing item, and we go up to 3.5 and just whack these puppies in. Add as link. How come you took so much smaller? What was that? How come you look so much? Great question. Righto, so if we build now, ooh, that's interesting. But there's a couple of things I need to do, which I forgot to do before. So let's quickly change these. So first of all, this is the assembly name with 40 on the end. And the default namespace needs to be this. Okay, so we save that. Then we go to build and we stick in our ... And in release we do the same. ... Okay, go back to debug, and in our build events we need to copy the assembly over. Now here we may have actually hit our very first issue, our directory service. So clearly we need to include a reference that we haven't included. So we've got data.dataset extensions and system.directory services. So let's add a reference, which is a standard assembly, to system. What are we? Directory services. This one here. Okay, let's build that. And that looks to have built cleanly. So now we should have excellent. That's what we're looking for, yeah? Buy a bigger screen, compression. Okay, so the good thing about this is that like clearly things are actually working the way we want them to work, which is exciting. What I am going to do is just exit exit -y. So I'm going to vim local.rc. Now you see what we've done. Where are we? I'm going to copy. No, I'm not. I'm going to move the local RC to local 35.rc. And I'm going to copy local 35 to local 40. And then I'm going to vim local 40, because local 40 is going to have, where are we? Set CLR version net 40, right? I'm pretty sure that's what we need to do. So then we should be able to MSF console local 40 and watch it shit itself because I've done something wrong. See what happens. Yeah, there you go. Options. CLR version net 40. Ah, there you go. It's got to be lowercase. Can't type. Let's vim that baby. I hate how this stuff is case sensitive. Let's do that again. Now the sessions that we should have seen just pop straight back in are the ones that we're continuing to run. There you go, look at that. That's the native session that we ran before, so we can see it's just picking straight back up, which is awesome. Okay, so you can see that we have .NET 4 version of the CLR. Now this is really important. CD Metasploit, code Metasploit framework data interpreter. Now we have to create a symbolic link to Scratch metserve 4 and to ext server standard API 4. Because inside here you'll see that we've got these puppies here. I've got them symlinked to where the post build event copies the assemblies over. And the reason I've done that is so that every time we build, we copy the assemblies over across the file share, and the symlink references the file share so that when we serve Meterpreter up next, we get the latest version of the one we've just built. Does that make sense? So that's what that's all about. Now that those symlinks are set up, it should be able to find the implementations that we're looking for. But what we now need to do is create a new project targeting .NET 4, which is just going to be a straight Windows console app, and we'll call it test console .NET 4.0. Now this doesn't have to have any references or anything like that, but what I'm going to do is basically do the same thing. We're going to go add, I'm not going to go manage new game, we're going to go add existing item. I'm going to go up to test console 3.5, select that, add as a link. So all of this stuff should be the same. Now what I'm going to do is just get rid of this net 3.5 reference here. So let's just quickly change this. Save that. Properties. We'll save this too so that we can share the source across all the things. Set this as the startup project. And build it. It built. See what happens, shall we? And it crashes. Oh, now this is interesting. So you see we've got this adapter address. So the field isn't there. So this is a perfect example of where .NET 4 and .NET 3.5 have an underlying implementation change. One of those symlink paths is not like the others. Huh? What? Who? No, that's fine. This is actually works. Like, as you can see, our .NET 4 version is actually running. Look, let me show you. Do this again. We'll go view, debug. Where are we? Windows. Modules. Where's the module window? There it is, modules. So look, Metserve 4. Standard API. Oh, check this out. Is that what you were talking about? We've actually got the wrong standard API. Did I do something stupid? Or is this because the version that's loaded I don't actually understand why we're not seeing warnings here now. In your directory pointing to scratch, one of your paths was different for one of the files. It was. Thank you. Let's go and fix that. CD code data. Metasploit framework data Meterpreter. Net 4. Net 4. No, it's all good. Oh yeah. Isn't that interesting? But that's the one that we had existing, so it shouldn't really matter anyway. Yeah, that's fine. That still works just fine. The problem we've got actually is this one here. That's pretty interesting. I'm going to come back to that just for now, but at the moment that's not concerning me. The thing that's concerning me is that the modules that this thing is claiming to load. So we've definitely got .NET 4 of Metserve, but we've only got .NET 3.5 of standard API. So this has probably got something to do with the way that, we are wiring things up in our implementation. So let's just have a quick look. We'll go ag CLR version in lib. No, it's not in lib, is it? It's in modules. Oh, I can't type. It's CLR version. Right, so this is the Meterpreter loader doohickey here. Yeah. let's load that up. And CLR version. Standard error dot puts loading. Let's go. This 2-second thing that I said that we were going to do is now going to take much longer. Let's just load that up in gbim for now. Exit out of that. We're going to exit out of that. And I'm going to reload MSF from that. I just want to see which one is actually loading based on the CLR version, because I'm really hoping that that is doing what I had planned it to be doing when we first kicked this whole process off. Look at that, there you go. It is actually loading the right one. It's loading metserv net4, okay. Ah, okay, so we know that metserv is working. We know that metserv is working. That's not the problem, is it? Oh, crikey. That's not our problem. Okay, so let's get rid of that. Ag CLR version. Yeah, okay, so ag net35. Maybe we've got this hard coded somewhere. Here it is. Here it is. Okay, so this is one of our overhangs where we've got we need to support different versions of the framework. Okay, so let's go grep. No, ag again. Binary suffix in lib. So we should see that when we pull out, when we're actually loading our extensions, we should be able to say, where are we? I don't think it's in here. I'm just trying to remember exactly where this is referenced. So the problem that we've got here is that our binary suffix varies depending on the CLR version of the target, yeah? Oh, did you guys just cop a bit of a issue with the stream? Sorry about that. I don't know why that was happening. Yeah, sorry about that. I didn't know that was a thing. I got no notification that things were going poorly. But yeah, sorry about that. Let's open up client core. Binary suffix. Okay, so load all the extensions. Okay, so when we get the binary suffix out of this from the load library, which actually makes sense. If it's an extension we're dealing with, rename the library path logo. Yeah, we don't care about that. That's actually just shit that we're passing in remotely, which we're really not fussed about. We are fussed about this. So, do we have the binary suffix here? Now, what we want to be able to pass in is, you know, .NET 4.0 versus .NET 3, which would require us to say, let's have a think. So we're back in that realm that we were concerned about a little while ago. Can we actually specify a configuration option, or do we actually have to have CLR 4.0 versus CLR 3.5 as actual platforms? You know what I mean? That might be what we're going to have to do. So if we go here, so our platforms we got here, we got x86. We might actually have to go, if we move this to, what would it be? I don't really want to duplicate this stuff because we're literally only changing a version number. Everything else stays the same. So you know what, I'd rather deal with the pain later on. Let's not worry about that just yet. Let's go back to debugging our thingy, because what I want to see is when we reference this get private field. What's interesting about this is that 3.net 3.5 version actually worked in our .NET 4 loader. So I wonder if we can abuse that somehow. Oh no, it only works because I have 3.5 installed. So here, okay, let's hit a breakpoint here and watch it shit itself because I didn't build it properly. Oh, and because I don't have our listener running. Sorry. We'll come back to that. Yeah, I don't want to have to add a new platform in that way. That would be rubbish. Now, remember, on our address object here, we were reaching into the non-public. Oh, look at that. It's hanging off the address. It's right there. It's there, right there. Why is it right there? If net40 else return uint addr prefix. Unicast does not contain a definition for prefix length and no extension with prefix length. Isn't this interesting? Should it be lowercase? Wow, dude. You make a very good point. Did I actually remove that? Or did I not? Oh no, it's in Metserve, isn't it? That's, oh, I didn't do it consistently. Properties, that's why it's shitting itself. Okay. Barney, you have just saved me, by the way. Isn't it? Now, what have I just done here? No, it's not case sensitive. It clearly isn't case sensitive. Properties. So what I need to do is, the thing is, like, according to the docs, it does say that already, right? The build system is aware. These are all uppercase. Build systems where predefined pre-processed symbols representing target frameworks. They're useful in creating apps that can target more than one .NET implementation or version. So why this is the case, I don't know. But like, where are we? Let's go back to that. Remitserve extensions, unicast IP. I've got to get this done and working. because we're running out of time. Let's rebuild solution. Okay, so let's do this. Properties. Net 40. Rebuild solution. Yeah, it's like it's not. It doesn't like it. I'm just going to clear that out for a minute. And I'm going to leave this here. I'm going to build it. So this is a system network information, system unicast IP address information. And it has a prefix length on it. Is it because we're not working off a system unicast IP? That might be why. Ah, that's internal. That's why. Okay, that's okay. We can work with this. Maybe we can just, instead of getting a private field, we can get a private property. Let's just do this for a sec. Pref equals addr.get private property of type. What was it? An int? It's supposed to be an int. Prefix length. So let's go and do some more reflection magic. And not get type, get property. Okay, that should give us the property. Now what can we do here? Property dot, let's see, get value. So we need to give it the object. And what else? Ooh, binding flags. Why do we need to give it all of this nonsense? Returns the value of the property with the optional index. Returns the value of the property with the optional index values. Index. Can I give that null? This should be get private property. So what happens now? Property is null. The object is definitely a system unicast for whatever. And prefix length is definitely there. So what are we doing here? It's maybe the binding flags are wrong in this particular case. Is it private or is it protected? Let's run that again. Okay, so prefix length. According to this, on that particular type of object, it's public, otherwise it wouldn't be there, right? But that just includes non-public stuff in the search, right? Specifies that non-public members are to be included in the search. Maybe we also need to go public. There you go. How dumb. I have to cast it as well. Gotta love it, eh? What do we got now? Oh yeah, okay, so the reason why that's breaking is because we are. I don't know why the symbol names aren't correct, but I'm going to keep it as capital. We're going to save that, and I'm going to do the same for standard API. Application build. I would have to do this for release as well, wouldn't I? All configs. Let's all configs. Well, well, well. Oh, wow. How exciting. Now, what I do need to do, we've got CLR/CLR, but what I would like to put in here is CLR/net35 or net40, so that we do know. And so the things that we need to, let's pretty much bang on 10 p.m. So I am going to stop there, but where we're at now is we need to go through and make an effort to tidy up that whole network interface stuff, because that is an absolute dog's breakfast. So that's going to be added to the to-do list. We need to sort out the version information in this Meterpreter, just here. And in doing that, we also need to sort out the binary suffix to make sure that the right version of the .NET assembly is loaded based on the configuration, which could be a little bit of a dog's breakfast, but I think there are a number of ways that we can actually manage that. I may have a play with it off stream just to come up with some options, and then I will go, okay, look, I went and played with all of this, and this is what I've come up with, and this is why. And I think that's actually useful to do off stream, because that's not so much sort of the Meterpreter building that's the problem, it's more of an MSF related shizen. So I think that's entirely reasonable. All of the get systems, wait until we start implementing get system on stream. You guys are gonna love that shit. Anyway, 10 o'clock. I've hit my 2-hour limit. I'm gonna hit pause there. But thank you. Thanks for joining in. It's been lovely having you all on board and chatting and offering insights and suggestions and all of the wonderful things that you guys normally do. I am very grateful as always. So yeah, anyway, look, I realize that we're not exactly going at a massive pace here, but I'm still trying to find that balance. I'm open to suggestions. Hopefully you guys learn something. But if you do have some Insolent Fools here. If you do have some questions, particularly about the reflection stuff, please hit us up. I'm happy to answer. Smash has obviously happened to answer as well. We will lose our shit. That is when all of the get system emotes will be used. So yeah, maybe I need another special emote for that day. So the paper's perfect. Okay, that's lovely. The reflection was doing my head in. It is a bit shitty, hey, like reflection is a mess, but at least we're using C# and not C++, as Smashery has alluded to already. But it is a bit of a magic wand, bit of a pile of shit at the same time. So anyway, we have made progress, and we have many more things to do. But as always, I'm very grateful for your support. I am planning to get back in again on Thursday. Every time I did that reflection stuff, I called the function. I know I'm a bad person, but get private. Yeah, that's probably what we should rename it to, Smash. So, I guess I don't really have that much more to add. In summary, we're going to come back to this again, tidy a few loose ends up. We probably live a little bit more in Metasploit land to try and get our wiring correct and our versioning correct. Because we don't want to just leave that as is. But, in the meantime, thank you again for your support. Hit me your questions on Discord or on Twitter, and hopefully I'll get to see you wonderful humans again sometime on Thursday evening around about the same time if everything goes to plan. So, much love. Chat to you soon. Be good to each other.